The atmosphere in a sealed diving bell contained oxygen and helium. If the gas mixture has 0.300 atm of oxygen and a total pressure of 3.70 atm, calculate the mass of helium in 12 liters of the gas mixture at 25 degrees Celsius. So let's solve this problem step by step. So step 1 is to solve for the pressure of helium. How do we do this? We make use of Dalton's law of partial pressure. So according to Dalton's law, the total pressure, P total, is equal to the sum of the partial pressures of all the gases. So in the problem, we have two gases, oxygen gas and helium. So the total pressure is equal to the pressure of the oxygen gas plus the pressure of helium. And when you read the problem, the total pressure is given. It's 3.70 atm. So total pressure is 3.70 atm. And the pressure of oxygen gas is also given, 0.300 atm. Therefore, you can solve for the pressure of helium. So how do you do this? You just transfer 0.300 to the left side and it becomes negative. So 3.70 atm minus 0.300 atm. This is the pressure of helium. So if you solve this in your calculator, 3.70 minus 0.300, that is 3.400 atm. So this is the pressure of helium. So that's for step 1. Step 2 is to solve for the moles of helium. So calculate the moles of helium. And how do we do this? We will use the ideal gas equation. If you can recall, the ideal gas equation is PV equals nRT. So P is pressure, V is volume, N is the number of moles, R is the gas constant, and T is the temperature. So we will solve for the number of moles, so we are solving for N. So to solve for N, you divide both sides by RT. So RT will cancel on the right side. So your formula becomes N is equal to PV over RT. Now let's solve for N. According to the problem, the pressure, we solve for the pressure of helium in step 1, that is 3.400 atm. So again, we are solving here for the moles of helium, so N of helium. Therefore, we will be using the pressure of helium. So the pressure of helium again is 3.400 atm times V is the volume in liters. So according to the problem, that's 12 liters. So let's put 12.0 liters divided by R is the gas constant, 0.0821 liter atmosphere per mole Kelvin. This is something you should be familiar. And then T is the temperature. Now take note that when you are using the ideal gas equation, the temperature is in Kelvin. In the problem, we are given temperature in degrees Celsius, 25 degrees Celsius. So how do you convert degrees Celsius to Kelvin? You add 273.15. So again, if you want to convert Celsius to Kelvin, so we have 25. All you need to do is to add 273.15, and that becomes Kelvin. So let's see how the units will cancel. Kelvin will cancel, ATM will cancel, and liters will cancel. So our remaining unit is moles. So if you solve for the moles of helium, plug in the numbers into your calculator. This is equal to 1 point, let me just write that, approximately 1.6668 moles. So this will be your moles of helium. Let's read the problem again. It's asking for the mass of helium. Calculate the mass of helium. So the last step in solving this problem is to convert moles of helium to mass of helium. So step 3 is to calculate the mass of helium. So we have 1.6668 moles of helium. When you convert moles to mass, you need the molar mass. So the molar mass of helium, the molar mass of helium is 4.003 grams per mole. So you put 1 mole of helium below, and above you put 4.003 grams of helium. So the moles of helium will cancel, and now you have grams of helium. So if you solve this, 1.6668 times 4.003 divided by 1, this is equal to 6.67 grams of helium. So the answer to this question is 6.67 grams.